So on page 46, we're looking at hydrostatic force and pressure. Right. So definition of fluid pressure: the pressure on an object at depth h in a liquid is P equals WH. W is the weight density of the liquid per unit of volume. So that's a fact or a piece of given information. Right. So we're typically going to work with items or objects that are submerged in water. Right. So that's the 62.4. So we're going to look specifically at Pascal's principle. Right? It states that pressure exerted by a fluid at depth h is transmitted equally in all directions. Right? Now, I'll just read the rest of the blurb. Because fluid pressure is given in force per unit area, the fluid force on an object at a given depth would be the pressure times the area of the object. Right? So it's just modifying the P equals F over A to solve for force. All right. The issue is you could have multiple types of orientation of an object. You could have it vertically submerged. You could have it horizontally submerged. All right. So what that would mean is that the entire object is at the same depth. All right. So the level of force would be at the same level throughout. Right. So the other possibility is if it's vertically oriented, then depending on the depth or the height of the object, you'd have a different amount of force applied to that object. Right. So what we would want is the cumulative exertion of force upon the object, but that would depend on the different level in terms of height or depth. Right. Now, there's also oblique orientations, but we're not going to get into that because that's a little bit more complicated. All right. I found a nice video explanation. When I was first learning this, I needed some resources, and this is where I went. So if you don't like my explanation, then maybe this would be a place for you. All right. So the first example is the case, the simpler case, which is uniform depth. So find the fluid force on a rectangular metal sheet measuring 3 by 4 that's submerged horizontally in 6 feet of water. All right. So we know, again, we're looking for fluid force. So F equals PA. All right. Now, again, P is defined as WH. So F is equal to WHA. All right, so W again is the weight density. It said water, so 62.4 given. All right, now they're in pounds per square foot. So we want to keep that in mind. So pounds per square foot. The height or depth, 6 feet of water, and the area 3 by 4 is 12 square feet. All right, so that's our area. All right, so feet squared cancel, and so we're just looking at the product of these measures. So 62.4. Oops. Times 6 times 12, so times 72, is going to be 4492.8. And that's, well, the only things that are left are feet and pounds. So that would be our units, foot-pounds.